Let us solve this second order system of ordinary differential equation. It's a linear differential equation with two parameters, alpha and beta. We're going to use the ode45 method to solve this. Let's define a function, call it sol. You can call it any name of choice. Let's define a state vector to hold x and y solution from the system. This implies that x is state 1 because x is in the first slot of the vector, and y is state 2 because y is in the second slot of the vector. Now let's define a function, a lambda function. Let's give it the name ode45. Of course, you can give it any name of choice. This function is going to hold the ODE system. So the first equation in the system is alpha times state 1 plus state 2. And the second equation is state 1 plus beta times y, which is state 2. Now let's solve this system. First, you will recall that alpha and beta are both -1. I don't want to be passing in the parameter right now. We're going to look at that in another video, how to pass parameters when you call the ODE function. For now, let's just define it, hard code it as 1 into the system definition. Now let's solve it, and let's use t and state to hold the solution after we have applied ode45. Now we'll pass in the function ode1. Next, we pass in the time span, 0 to 8, because we want to integrate from 0 to 8. And let's pass in the initial condition. According to our definition, our initial condition is 0.1 and -0.5. Okay, so you can see right here. The comma is not an error, but I just want to be consistent with the way I define the initial condition vector. You can leave the comma there if you wish. Next, let us pass out the solution when we call the sol function. Okay, so put it up there. I made a mistake there. I just corrected that to state. Okay, you'll notice that the state is local to the lambda function is different to the state holding the solution, which is global. Okay, and MATLAB does a good job to highlight the states that are the same in the local function and not highlight the one in the global space. Okay, I could have used a different variable name, but since the state in the lambda function is local and not directly accessible by the state in the global space, that is the one holding the solution, this isn't a problem at all. Okay, the scope of state in the ODE form in the lambda function is local to the lambda function, and the state that is holding the solution, ode45, is global. So they are not in the same scope, okay? Okay, basically we are done with the solution of this ODE. Now we can solve by calling it in the command window, call the function. If we use the expression whostates, we can see that states it's a 61/2 matrix. Let's open it up. You can see that. Now, the first column holds the solution for x, and the second column holds the solution for y. Therefore, we can call x by saying state, column 1 of states, that is x. This is the same thing as saying state from 1 to end in the first slot, and 1, that is the first column of states, and y is states, the second column of states, as we saw in the command window. Now let's plot t against x and t against y. Let's make y black. K means black. Black, a dash dot black line. Okay. Now let us call the function again in the command window. Okay, here you go. As you can see, this is the solution. This is the output that we get for x and for y. Please do well to subscribe because more videos like this are coming. Thank you.